Hello everyone, this is in continuation with my previous uh, lecture. So let me continue that session here. The problem is not yet over. So now in the last lecture, the last value we have written there is the second row of generator matrix, which is p raised to the power n minus t. Since t is equal to 3, so p raised to the power 7 minus 3 plus r3 of p. So p raised to the power 7 minus 3 is p4 plus r3 of p is p square plus p plus 1. So this equation will gives us the second row. Now let us put up the last value of t, which is 4, and this will giving us the first row of generator matrix. So to get that, first of all, what we are doing, we are going to divide the we are going to find out the value of R4P, that is RTP, which is remainder of p raised to the power n is 7 minus t is now 4 divided by g of p. G of p is p cube plus p square plus 1. So first of all, we are going to find out the R4P, and then later on we will try to write the first row of generator polynomial. So let us make the division p cube by p cube plus p square plus 1, which is generator matrix. So since p cube here, it means what we will have to multiply this p cube by 1 only. So 1 into this will be p cube plus p square plus 1. P cube will be cancelled. So what will left? P square plus 1. No more division possible, as the highest power of this remainder is less than the power of this denominator, highest power of the denominator. So this is what R4 of P. So the final value that will gives us the first row of generator matrix is p raised to the power n minus t plus R4 of P. This is what the value of first row of generator polynomial g of p. So p raised to the power n minus t, n is 7 minus t is now 4, so 7 minus 4 is 3 plus R4 of p is p square plus 1. So this equation will gives us the first row of generator matrix. Now let us write down the generator matrix. So the same way as in the last lecture we have done, we are going to write the generator matrix. How? So before writing the matrix, first of all, we can write all the polynomials variables here with their powers. So p0, p1, p2, p3, p4, p5, p6. We know that the number of rows and number of columns in the generator matrix, as the standard size is k by n. So k is 4 here and n is 7. So 4 rows and 7 columns. Now let me write here the first row. So which equation gives me the first row? So this is the last equation that will gives me the first row of generator matrix, p cube plus p square plus 1. So I am going to write their coefficients are 1. So p cube's coefficient is 1. You can see here p cube's coefficient is 1. P square coefficient is 1. And 1 means what? It is p0 coefficient. P raised to the power 0 is 1. So p0 coefficient is 1. The rest of the coefficients are 0. Now to write the second row of generator matrix, we'll have to look at last but one equation. So that is this equation, second row. So p4, p square, p and 1. 1 means p raised to the power 0. So let us write their coefficient. P0 1, p coefficient is 1, p square coefficient is 1, and p4 coefficient is 1. Rest of the coefficients are 0. Now let us write the similar way. We can write third row and the fourth row from the second equation and first equation. This is what the second equation, which will gives us the third row, and this is what the first equation, which will gives us the fourth row of generator matrix. If we see p6, p square, p, fourth row. So p6, p square and p coefficients are 1 and rest of the coefficients are 0. This is how we can write a generator matrix. Now if you see this generator matrix is having an identity matrix here. You can see the diagonal elements are 1. So it means this is the generator matrix with systematic form. So this generator matrix is available in the systematic form, so it will be producing the cyclic code word in the systematic form also. So how to get the systematic form of cyclic code word? Once again, by using the same formula, C is equal to dg. This is what the value of P is the arbitrary matrix. You can see this is the generator matrix. So if this is identity matrix I, this will be any arbitrary matrix P. Any generator matrix is made up of two things, arbitrary matrix and the identity matrix. So if this is I, this will be P matrix, which I have written here. Now how to get the cyclic code word in its systematic form? Simply once again by using the same equation, C is equal to D into G. So D, it is mentioned in the numerical question, it is mentioned in the question, and G is the generator matrix which we got. So if we do this matrix multiplication, row by column, row by column, row by column, we will get this value C. Now if you see this code word C, the input is appeared at the last as it is. It means what? This code word is in its systematic form. This is what the way to get this code word in the systematic form. Since the generator matrix is in the systematic form, so it is producing the code word also in the systematic form. Now the final question was to find out the code parity check matrix, that is the H matrix. So to write H matrix, you must need to know H is composed of two things. It must have an identity matrix and it must have a transpose of arbitrary matrix, P transpose. So basically the P matrix which we have already written here, right? So what we can do, we can take a transpose of this matrix and we can write it first. So what we can do while writing the H, first of all, we can make the transpose of this matrix. Transpose means what? Replacing rows by columns. So 101 we can write it as column, 111 this column, 110, and the last column is 011. So once we have written this, now we need to write the identity matrix here. So since how many rows are here? Only 3. So it means we need to write an identity matrix with 3 by 3 size. This is how, what the way we can write the H matrix.